So we have a special guest from Sweden. And yes, welcome. Floor is yours.
Thank you very much for having me and inviting me to this seminar. I'm very sorry for not speaking Finnish, but I did try to understand what you said. I did understand a bit. So please interrupt and ask questions whenever you feel unsure what I'm saying. My background is, Kari told you, I've known Kari for some years now, and I've been working with this industry since the early 90s, and always with transport and logistics as a basis. Let me see now what's happening now. Which one is it? I need to go into that mode, maybe. Change mode, I guess. I did, but it takes some time. No, it's not the same. My slide is just stable. You don't mirror the screen, but I can look here, it's fine.
Okay.
I don't even know which button it is, that one or... But if I want to go back a bit...
No, now it's not working at all.
This one is working fine, but... Yeah. So while we are waiting, this one is fixed, so this will be my only slide for the whole day. Anyway, so I can maybe start a bit. So what we have seen in society, we have seen how society have realized that there's something wrong here with the environment. At the very beginning, it was very local problems. So there were local focus, and one of the first international conferences, UN conferences, was in Stockholm, 1972. And that was quite focused on local issues. And then in Rio de Janeiro, 92, was the second one. And you could see a trend towards more global issues, more climate change issues. And that continued into Kyoto and Copenhagen, and right now we have the conference in Bonn, very much focusing on global problems, environmental problems, and climate change primarily. From industry or standard initiatives, I mean, industry wants to have a standard to keep sort of a grip on, and one of the first one was ICC 16 points, launched in the early 90s, how to behave as a company. And that moved on to ISO standards, ISO 14001, for example, environmental management. And then came the GHG protocol, greenhouse gas protocol, in the early 2000. And then, as Kari already mentioned, we had this European standard, EN 16258. It was launched in 2012, or the very end of 2012. And a funny story about that was that we had some 3 years that we could do it, and you must not exceed that time. So we had to launch the standard just before 2013. And I think we launched it just 1 hour before or something like that. And after that, now we can see another trend moving on, using this European standard as a basis, where we are moving on towards a global standard. Okay, I don't push anything about that one. I promise. Thank you. I'll go back a bit. And now what's happening in right now, it's initiatives trying to, this was a European standard, and now to move on to a global standard. It's something called Global Logistics Emission Council working on this. And we are right now doing a European-funded project called LEARN, and trying to look into this. For NTM in our history, it's very much linked to this global development where we launched our organization in 1993. And we've been struggling to come up with new data and new tools and methods the same period. So linked to this globalization or climate focus, you can see European Union are now focusing a lot on reduction. European Union climate targets on different sectors, you can see here. I think we have a big challenge. I think if I understand you right, I mean, Finland are doing the same as we are in Sweden and all over Europe. But we have a lot of strain and difficulties to overcome. I just spoke to someone yesterday about e-tailing, how we are now ordering online food and shopping clothing. And the number of clothing that you send back today, you order 3 and send back 2. So we're all the time increasing transport activity and having problems to make it as more efficient as we have to. So we are increasing demand of transport. Anyway, so we have to do a lot. So, and also going back a bit to Kari's presentation, what has been in the past a lot of focus on air quality has swapped and changed towards focus on climate. But it's sort of going back a bit now, and if you go to China, for example, or other Asian countries and cities, you have a lot of focus on air quality because people are dying beforehand because of bad air quality. So this is really sort of a trade-off a bit sometimes, and I think you must not forget these issues. They didn't disappear. Of course, I understand this is very important, but also air quality is important, and that's also the basis for our model, and also for Lipasto. So how do we assess emissions from transport? And now I'm focusing a bit on greenhouse gases. Well, it used to be that we only looked, also repeating a bit what Kari said, we used to just look into the local emissions from the vehicle itself, or the vessel. And this, of course, gives the tank-to-wheel emissions. But if you want to compare electric vehicles with combustion-driven vehicles, you need to go behind the scene and look into the fuel and the fuel composition. So then you have the well to tank. And of course, this is a bit problematic to have this data, but we have data that we can use as default numbers. And if you take the whole, it's well to wheel. So this is really the challenge to look into all this. And of course, if you monitor differently, you have different results. So have the same thing again. You extract the oil from the ground, you refine it, and you put it in a car, and you burn it, and you have emission of fossil carbon dioxide. And within car industry, for example, you measure emission of carbon dioxide per kilometer. So that's the standard right now. And then if you use more and more biogene sources or biofuels, there's a small fraction here of biogene carbon dioxide that's being emitted. And the pre-assumption is that is going back in a loop for growing new fuels, basically. So having this well-to-tank, tank-to-wheel approach, the way to measure this is, of course, could be misleading sometimes. So if you have, for example, within cars, you quite often use CO2 fossil when you take the grams per kilometer. Whereas for other modes of transport, you use CO2 equivalent, where you put together CO2 fossil with methane with laughing gas. And I know when we launched this standard, Kari and I was part in that process, as you know, the bus industry was quite upset because buses, they needed to measure this one. But car industry had for a long number of years used this one. So they came out not as good as the bus. So you have to understand the numbers you receive. For our network, NTM, the main objective is to act for a common and accepted method and data for calculation of emission and also natural resources. So that's basically what we do. And we were formed in 1993. We are including all modes of traffic, freight and passenger. We do develop methodologies, data, and tools. The primary target group, which is quite linked to your network here at Logi, is shippers and transport service providers. And we also have dissemination programs and seminars, even though it's not our primary objective. Our primary objective is to provide tools and services. Something we do not do, which is important, we do not take a stand. If we have a question from the Swedish government on something, we don't say anything. We want to be neutral. And this is key for us, because we want to be credible, so we cannot take a stand in specific political issues. So how do we work? We work with measuring present situation, where we use NTM Calc. I will show you that if we have time. We also want to see provide some benchmark, because it's quite difficult if you receive a number on emissions like 10 tons of CO2 or something. What's that? So we try to put up sort of baselines on typical values for a typical truck or a typical ship, and that we call NTM ECAP. And then, of course, you want to improve. Just measuring where you are, I mean, that's more or less useless. You have to work on improvements as well. So we try to communicate on best practices. And of course, it's quite complex, but we do work a lot with standardization. A lot of focus right now is on fuels. I think you talked about fuels a bit before. And at the moment, I'm not sure about Finland, but in Sweden we have a lot of focus on HVO. Is that something here as well? It's quite funny because ethanol used to be the big one in Sweden. And right now, due to political and pricing mechanism, we are shipping a lot of ethanol to Germany and importing a lot of ethanol, HVO from Germany. And of course, if the price changes, it will go the opposite direction tomorrow. So I'm not sure if we are very long term in this. It's very much adapting to realities. Anyway, HVO is the big hero right now in Sweden. I'm not sure if that will be tomorrow. So how do we work? This is an illustration. So it's not trying to communicate how we work. We have a platform illustrated as a car platform. We have an organization, we have resources, we have an IT infrastructure. And for that platform, we have an engine. For us, it's our methods and our algorithms. And then, of course, we have the tank where we have data, all kinds of data, method-based data where it comes from models, similar as we had before. But we also look now more and more into operational data, where we try to get in touch. You talked about digitalization, and we have a lot of work going on right now, capturing data directly from the CAN bus in the vehicle. And that's for sure coming. Our main problem is not the data itself. The main problem is we have too much data now. What is what? Why is the track standing still? Is it loading, unloading, having a coffee break? How much cargo is really on board? So now we have problems with that, but I think that is coming for sure. So having this, we can build our models. And this one is a model we have. I will show you NTM Calc. But of course, the key aspect is here, our neutrality and credibility. And we also build other sort of tools based on this platform. We have this ECAP I told you about, putting up baselines. trying to help companies to improve NTM Delta. And we also provide this through web service, APIs, where they can build their own applications. TNT, for example, is hooked up with us, and they can do their transport evaluation, sort of calling us through web service as an API. And they can do a very sort of good calculation. And we see a lot of different companies doing this, and I think that's sort of the trend of today, where you have built apps based on some platforms. And we also build one app for the Commission, a corridor calc, where they can do calculations on transport corridors in Europe, and also put money, external cost for emissions on that. The website is sort of showing basically the same thing, where we have NTM Calc, ECAP, best practices, but also methodologies. And then we do some other communication here as well. And this is the tool, and just a screenshot. So I skipped this one, so I can go to the live show later on. This is what we can see right now coming up. A lot of companies, one of the key driver right now is these kind of companies, the software providers within transport logistics. These are some examples, you may know some of them. And they want to incorporate environmental calculations as well in their offer. So this is one example from PrimeLog, where they have quite advanced tool for logistics evaluation, but they also want to incorporate environment data. So they just hook up with us, and they can just, as a user of PrimeLog, you can just swap the screen to environment, and then you have very good ability to do evaluation. And they haven't developed anything, they just hooked up with us. They have a lot of good data, they can sort of link to us, and that makes it quite good. And of course, again, more and more operational data, advanced routing models. A lot of shippers don't know the routing of the transport, and that is, of course, essential if you want to make a good calculation. Yeah, repetition. So what are we doing now? Well, within this EN 16258, it's a well-to-wheel approach, already mentioned at least 2 times. That's the standard, where you incorporate, you do the CO2 equivalent, where you put together carbon dioxide, methane, and laughing gas. Something that GRI is recommending is to also describe your emissions, the biogenic emissions, even though they don't add to climate change. You're supposed to put that up as well on your screen, or your total performance. Also, energy use. I think energy use is the best key performance indicator, actually. Because if you become more and more energy efficient, that's always good. But if you swap to another fuel, reducing your CO2 equivalents, and assuming that you go for HVO and doing that, and tomorrow HVO is seen as a bad fuel, so your improvement will not as stable as you maybe wanted. So energy efficiency is always right to me. Something that was much debated in the standardization process was if you go one way, so full load trucks, and going empty back, who should pay for that, those emissions? And I normally do this sort of a Gallup survey when I do this kind of presentations. If I have shippers here and transport service providers here, so if I ask the room, who should pay for these return trips? Not pay, but for who should be responsible for these emissions? The shippers, they say, oh, it's the transport service providers. And the transport service provider, oh, it's the shippers. So the point is, these emissions occur, and somebody has to be responsible. So if I take a taxi now to the airport, the taxi needs to go back. Should that be my responsibility, or is it the taxi driver? Who should actually be responsible? And of course, that's an endless discussion, but you can't just leave it because it's happening. Something that was also decided is you cannot include offsetting measures. Of course, it's good if companies do offsetting, investing in offsetting things, but you must not include that in your calculations. It's sort of it's something beyond this accounting. If you have a good set of standardization principles that we are following, maybe we can do this kind of assessment. I'm not very convinced myself, but if we can, and this is an example from a company I work with, a big Swedish company, where they have a mix of long-haul truck, distribution trucks, and also train transport. And if you take this blend, the emissions of greenhouse gases are 70 grams per ton kilometers, and the energy use is 0.9 megajoule per ton kilometers. For this specific company, we also made some improvement work, and we introduced the duo trailer, the 34-meter long truck, and also introduced HVO fuel for some of these. And of course, we could decrease emissions substantially, like this. But the energy efficiency just went somewhat better, but not that much. And then we also, theoretically, this was never done, or it haven't been done yet, but then theoretically we moved all the trailers to the train, and the train were driven by green electricity. So then the results was this. So this is really what we want to accomplish, to have a very, very clear illustration of what's happening, that you can trust. Don't trust this one. And then you can see how you're improving. I just want to say one more thing. This is relative improvements. And they may not say anything, because it might be that you have a sort of rebound effect where you're making things much more efficient per ton kilometers, but at the same time increases your total transport work for some reason, which means that total emissions may increase even though the relative go down. So if you have a truck running around a lot of distance with a lot of cargo, have a lot of transport work, ton kilometers, that will go down through a lot of bad driving, but the relative emissions will go down and the absolute go down up. So it's you have to be aware of absolute and relative numbers. So to conclude, just to look into the future, I think what we will see and what's coming very much now is development driven by reduction of greenhouse gases. And this is a Walmart truck in the US. I think it's produced by Volvo, and it's semi-electrified, and it's also driven on alternative fuels. And Walmart is pushing a lot here to have this kind of truck. I think you have 10% power from electricity. And that means that uphill you can save a lot, and then you can recharge your batteries on the downhill turns, on the brake energy. And this is the car you have all seen, the Tesla. I guess Norway is the leading company, but you see them all over now. And electrification in private cars is supposed to be the cheapest car by 2025 or something, 23, Volvo says, and Volvo Cars, meaning that this will come. I know Volkswagen, for example, are planning to get rid of a lot of engineers soon, because they don't need as many engineers anymore with electric engines, because that's much cheaper and much easier technology. So it's really a big shift coming up very soon. I think you talked a bit about autonomous driving as well, and this is autonomous shipping. Well, this is a study, but I think this is coming as well. If you well, if you assume this is the main room for shipping, I mean, we could sit here, captains. We could be 10 captains in this room, controlling 100 ships all over the world, globally, and we can go home by night to our families as a captain, and still have a sort of shift 24 hours, and this will actually be more safe than today, they say, because the human eye is not as good as the cameras that these ships have. Another sort of positive impact is, of course, you can build them differently. You don't need a lot of crew area, and there's no use of hijacking these ships for pirates, because the hijackers want people. They don't want the goods. So why should you have? So maybe this is long term, but still it's coming, and digitalization, electrification, and automation is really what's coming, I would say. This one you don't want to fly with. Maybe not, at least. It's hydrogen. And of course, if you remember the Hindenburg accident, you may not want to go here. But I'm sure aviation is really under pressure to do something. And I think they will eventually do this, to fly with other fuels. They're still already doing that, but on a very small scale. So I think that's coming as well. Go shopping? Well, maybe not. I think this is, I don't remember the name now, it's Starship. It's a small robot. I think there are some Finns behind this, actually. At least a few ones in the crew. It's developed in the US, and sort of some people that made it in their previous lives, so they have money, and invested a lot in this. It can carry 9 kilos of cargo or food, and it's electric driven. Automatically takes your food to your home. I actually saw another application, not this one. It's a bit secret, but it's about garbage. So the opposite. So we have someone collecting your garbage automatically. So I think, again, this is coming. Have you seen this one? Anyone? So what is it? Yeah. So the Hyperloop is the creation of Elon Musk, this guy. And Hyperloop is supposed to, I think they're trying to get some funding for a pre-study, at least, for a Hyperloop between Sweden and Finland. Well, imagine sitting in this small, what can I say, compartment in 1,000 kilometers per hour in vacuum. And the emissions are similar to trains, electrified trains today. And they are building up a test site in the Nevada desert right now. So I haven't heard much about the progress on that, but something coming. So my last forward spotting is this one. You may have seen this one or not. Anyone know what this is? It's the new model Tesla. It's coming up, a new truck from Tesla. And of course, that's it's always been said to me from Volvo and Scania. Of course, they are biased. Electrification is not for us. It's for small cars or cell phones. But now Tesla is launching a new truck, electrified. We'll see how it works, but still, there is a lot of challenge going on. And of course, transport is really top priority from a climate change perspective. I'm not sure about Finnish numbers. I didn't have the time to check. But in Sweden, we have some 34% of all our greenhouse gases from transport sector. And if you include the shipping going in and out to Sweden, it's some 40%. So it's really the big challenge. Transport is really linked to CO2. So I think that is really coming up. Let me see now. So if this works now. can just, oops, sorry. I can just give you an example here how this works, hopefully. So I just give you a very quick. Am I running out of time? A bit? 1 minute. I'll make this very quick now. So where do we go in Finland? We go to Helsinki. Let's see if this works. So you have you can choose different modes of traffic here, and all the modes. This one is ship, which is difficult to see, and then you pick your truck in this specific case. Oops. So you pick our typical truck, and you add it. And then you can calculate on different ways. You can calculate on shipments or by the total vehicle, per total fuel consumption or distance you drive. So we take the shipment, you take it very simple, you take 10 tons, and then you can add, then you have the distance. And then you can, of course, change the Euro class to whatever you want. You can choose the road type. The fuel type was this, sorry. So maybe you have the same as we have, basically. And you can pick load factor. And the Euro class, we changed to Euro 6. And then you calculate. So you have all the emissions for this shipment, for this distance. The climate gases, or if you want to look into all emissions and fuel consumption. And then you can build up transport chains, how many as you want. So, going back to my, I don't know where to go now. Here we go. I mean, it's over, so thank you.
Thank you, Magnus. We have time for one question.
Crystal
No.
clear.
Okay, if not, then we move on.